project is Mini ATC language processing using automata theory concept. This project is implemented using Python programming languages. The main purpose of this assignment is to understand how automata theory concepts are used in compiler design and the programming languages processing system. This project is divided into three main types. First one is level 1. It identify recognition. Level 2 is lexical analyzer. Level 3 is lexical analyzer with parser. This project demonstrates concepts like DFA. DFA is stands for deterministic finite automata. It is used to recognize patterns such as identifiers and numbers. A DFA contains states, transistors, start state, and the except state. And firstly is what you mean by automata theory. Automata theory is the study of mathematical machines used to recognize patterns and the process strings. Next is lexical analyzer. The lexical analyzer reads the source program and converts it into tokens. Tokens includes like the keywords, identifiers, numbers, operators, and the delimiters. And the last is CFG. The CFG stands for context free grammar. It defines the grammar rules of the programming languages. The programs includes the begin, statement list, and the end. In the screen you are visible, it is a level 1 identified program, means identifier recognition. In this level 1, the program checks whether the given string is valid identifier. According to many ATC rules, identifier must start with the letter. Remaining characters can be the letter or the digits. In this code, is equals to input, enter, identifier. These lines take identifiers input from the user. Valid is equals to true. Initially, the identifier is assumed to be valid. Next is if not identifier is alpha, valid is equals to false. This checks whether the first character is an alphabet and if not, the identifier becomes the invalid. The next is for CH in identifier is 1. This loop checks the remaining character one by one. If not, CH is all num means this checks whether the character is the alphabet or the digit. If special symbol exists, identifier becomes the invalid. If valid means it prints the valid identifier. Here in the output we see that enter the identifier. If we enter the total 1, then the output is valid identifier means starts with the letter and the remaining character can be the letter or the digits. Once again we run. If we enter identifier is one sum, then the output is invalid identifier. The level 2 is many lexical analyzer. In level 2, a lexical analyzer is implemented. A lexical analyzer identifies the keywords, identifiers, numbers, operators, and delimiters. Here the tokens are used. Keywords. In keywords, we used begin, end, input, and a print. And the operators are addition, subtraction, multiplication, division, and equal. And eliminators are colon and the brackets. And in level 2, the first three line will check the mini ATC keywords and the program is equals to input enter mini ATC program means it takes the mini ATC program as the input and token is equals to program splits means it splits the input into tokens. Next, tokens is equals to program dot split. It splits the input into tokens. If token in the keywords means it prints the keywords as the tokens. If token is in digits means it prints the number in the token. If token is in the alpha, then it checks the identifiers. If token is in the operator and it checks the operators. If CH is equals to delimiters and it checks the delimiters. In this, if we run this program means mini ATC program begin, the input is begin int x equals to 10 print X. The output is these are all the operators. The keyword means it starts with the begin, and int x means here int is the keyword and x is the identifier, and x equals to is the operators, and these brackets are the delimiters, and this semicolon is also the delimiters. Level 3 is lexical analyzer and the parser. In level 3, syntax validation is implemented using the parsing technique and the CFG rules. This parser checks whether the mini ATC programs follows the correct grammar rules. CFG rules are program is equals to begin, statement listed and the end. And the statement types are declaration, assignment and the print statement. In this code, token is equals to program. Firstly, we start program is equals to input enter mini ATC program for the initialization for the input. Tokens is equals to program is equals to replace. These are the separate symbols into individual tokens. Def match is equals to expected. It checks whether the current token matches expected grammar symbols. Def is equals to identifiers. It checks the valid identifiers. Def is equals to numbers. It checks the numbers. It is valid or true or a false. Def is equals to experiment expressions. It checks the expressions. And def is equals to declare statements. Parser declares the statement. For example, int is equals to x. These are the declaration statements. Def is equals to assign statement. Parser will assign the statement. For example, x is equals to 10. And def print is equals to statement. Parser print statement. For example, print x. Def is equals to statement. Checks all the statement has been printed or not. And def statement list is checks the multiple statements. Def program check. These are all the multiple statements have been printed. Def program check. It checks the complete mini ATC program. Int x is equals to 10. Print x and lastly the program is the output is begin x equals to 10. Print x and lastly the program is statically correct. Level 3 successfully implemented lexical analysis and the parsing using CFG and the recursive descent parsing techniques. The parser validates mini ATC program syntax and checks whether the programs follows the grammar rules correctly or not. And this level demonstrates the practical compiled design and the concept such as tokenization, syntax analysis, parsing, and a grammar validation. Now the DFA of the level 1, level 2, and level 3 are The level 1 of identifier validation DFA. The first selection defines the DFA specifically for the identify valid variable names. According to the rules, an identifier must start with the letter A to Z. Once the letter is detected, the machine stays in an accepting state as long as it continues to receive letters or digits. If they encounter special characters or displays, the identifier becomes an invalid. For example, A1, P2 are the valid states and one ABC are the invalid states because it starts with the number, not an alphabet. Level 2 diagram of mini ATC lexical analysis are. The second section describes the more advanced DFA used to categorize the various tokens in the programming context rather than just validating identifiers, and this machine branches out to identify numbers, operators, and the delimiters. It effectively sorts input into specific categories like the keywords, numeric values, or the flags, them as the invalid tokens. If they contain illegal characters, this multipath approaches the allows the analyzer to break down the stream or the text into meaningful component for the compiler. And the third one, the image displays the transition diagram from the pushdown automata, which is used to model the syntax of these symbols and used to model the syntax of these simple programming languages. This diagram illustrates how the system processes the list of statements by moving through the different states based on the input, token, and the current top of the stack. Here, first initial state Q0 to Q1 is the process begins by the pushing the static symbol onto the stack, and the next control state Q1 is that this serves as the central hub that decides whether the processor more statements are a branch into uh, a specific type of the statement, and the next is processing branches. Q2 is the processing branches. It is called as the declaration. It handles the variables declaration. Example int id, and the Q3 is the assignment. It manages the variables assignments. Example id is equals to expressions, and the Q4 is the print. It processes the output and comments. For example, is equals to print id, and the Q5 is the acceptance state. Once the input reaches the end and the stack is appropriately cleared, then the automata transition to the final state and signifies that the code is systematically correct. The DFA diagrams has been successfully designed and implemented for all the three levels of mini ATC project. Lastly, this project helped in understanding the automata theory, lexical analysis, parsing, and compiler design concepts used in real-world programming language processing. Future enhancement. In the project can be enhanced, adding a loops and a conditions, supporting floating point numbers, improving errors, implementing complete compiler features, and adding semantic analysis and the code generation. Thank you.